Hello everyone and welcome to another episode of Stable Diffusion for professional creatives. Today we'll be taking a look at the new version of my workflow for relighting and preserving details and colors for product photography. And we will see how with this workflow we can develop a pipeline that starts from this image on the left that is badly shot on a phone, which then gets rendered in a 3D environment and studio scene, and how that render can be used as a base for generating wonderful campaign shots, as well as animations, as we can see here on the right, all the while relighting the subject, preserving details, and preserving colors. This workflow is probably the most production-ready workflow that I've ever produced and released, and I think I can say that because I am actually starting productions with some brands. So a ton of you asked under my previous video if I could implement some stuff. Each and every one of you had different requests, and the way I usually work is by providing a bare bones workflow, something that you can expand on and make yours. But since a lot of you had requests to implement different things like IP adapters or other segment anything groups or color matching tools, I implemented all of that. You will be able to find this workflow in the description below, and this time you will be able to find all of the assets that I'll be using in the full pipeline from photography to 3D to generated images as well. So why do I usually only provide a bare bones workflow? Because if I do not, you get a monstrosity such as this. Now this is still usable as a one-click solution, but it's a lot less understandable than the previous workflow. So I have added a ton of notes telling you which groups can be disabled and what each group does. But as a quick overview, this center here is the same as the previous workflow, and I added an IP adapter group here for taking care of either all of the re-background or of regenerating parts of the set based on a segment anything mask that acts as an attention mask for the IP adapter group. Then we have a group that takes care of blending multiple segment anything masks together over here. Then we have a very quick and easy super upscaler group here, and by popular demand, not one, not two, but 3 different color matching options for preserving the colors of the original subjects. Now let's go through all of the workflow and what has changed. If you don't care about going through all of the workflow, you can just jump ahead, you have the timestamps for it, and see the whole pipeline, starting from a single badly shot iPhone picture and going all the way to a campaign-ready picture. So starting from the top left, you have your start from existing product image group. This is the same as the previous workflow, and it sources and resizes an image upon which we are going to do all of the work. Then we have a models group. Since some of you asked for a perturbed attention guidance node, I've added that as well. In the workflow you download, it's going to be disabled by default, but you can re-enable it. The only thing that you have to be wary of is changing the CFG accordingly into the case samplers, because PAG influences CFG values. Then we have our generate still live product shot group, and that's disabled by default because we don't want to generate random product. We want to start with products that are existing, but in case you don't have any product shots, you can use this one to generate a new product. Then going down, we have a background generator group. This group generates a new background that is either close to the one that we already have or very far from it. Now, some of you have asked for a way to integrate an already existing background, and that would be easy. You just have to blend the original image segmented with the SAM on top of an already existing background, but I didn't want to implement it in this workflow because that can be easily done in Photoshop, so I felt like that would mess things up here, given how easy it is to do it any other way. The new additions to the workflow are the IP adapter for background or selective parts group and the SAM for IP adapter attention mask groups. These two groups influence the background generator. They can be used together, or the SAM group can be disabled. If you disable the SAM group, the IP adapter group is going to work on all of the image, and if you enable the SAM group, the IP adapter group is going to influence only certain parts of the image. Like in this case, where the background is staying basically the same, but I'm influencing the wood branch in order to turn it into wool. For example, you can influence only the background, you can influence only parts of an image, you can influence all of the image. Then going towards the center, we have the segment anything group that takes care of segmenting out the original subject, and that's the same as the previous workflow, but we also have an optional multi-SAM mask composite group, and that's useful for those of you who are using multiple SAMs and need a composite mask of everything that is being segmented. Then we have our blend original subject on top of background group, which takes care of blending the original subject on top of our re-background image. Then we move on on to our Relight group, and I've rearranged this group to split it into two parts, one for the actual relighting and one for the mask alternatives group. Inside of the mask alternatives group, you have all of the ways with which you can create masks for relighting. Each and every one of them has an explanation in the bottom. So you can either start, like in this case, from an existing mask that you are loading into the workflow, or you can draw a mask yourself in the Open in Mask editor here, or you can use the color to mask node to influence the lighting based on the lighter parts of an image. This works essentially like an HDRI of sorts. That is a very loose term, but it's the closest thing, I think. So it uses all of the lighter parts of the background image as light sources for the relighting. Then we have a super upscale group. By default, it's set to 1.2 per, but you can just set your own rescale factor. It's bypassed by default because it takes a long time to calculate everything. So for demonstration purposes, while I record this video, I disabled it. Inside of it, you can find also an upscale original image and SAM group. And that's because, as I was telling you in the comments, if you upscale the Relight image, you also need upscaled SAM masks and the original image in order to properly use the frequency separation technique that we're going to see in a second. You can substitute the super upscaler workflow with any upscaler workflow you like, as long as you understand what's going on here. And it is both upscaling the Relight image and upscaling all of the masks and the original images that we are sourcing from for the frequency separation technique. Then we have the revolutionary core of the workflow, the optional pre-served details such as words from the original image group. Apart from having a very catchy name, this group splits the Relight image and the original image into a low frequency and a high frequency layer. The low frequency layer takes care of color and lighting. The high frequency layer takes care of details. Since we want details from the subject of the original image and the details from the Relight image that are not the subject, and we want the lighting of the Relight image, what we want to do here is create a new high frequency layer that is the blended result of the high frequency layer of the original subject and the high frequency layer of everything but the original subject of the Relight image. And this was the end point of the previous version of this workflow. But since some of you have been telling me that they had issues with the coloring of the subject, I'm providing you with 3 different ways of color matching the subject. Why 3? Well, for starters, that's because there's so many ways of tackling a problem, and I wanted to show you that. There's no best solution to it. There's just so many different ways you can try and solve stuff, and this is an example of this kind of mental approach. On the left, we have a color matching option that is employing a color match node. In the center, we have a color match option that is employing an image blending mode node set on hue, and on the right, we have a color matching option that is still set on color match node, but instead of using the segment anything mask for the subject, is using a light map. Option 1 and option 2 are the more stable versions of color matching. Option 3 is experimental, and I think it's interesting to people who want to see weird results and experiment with things in their life. So now that we've seen the workflow, let's get into the pipeline and see how we can get from this picture to these pictures over here. So the starting point is a badly shot picture of a product. As I was telling you in the previous video, starting from a good picture is better, but I wanted to show you that good commercially viable pictures were obtainable starting from a bad photo as well. Now, what I wanted to do starting from this picture was to insert it into a 3D environment and recreate a set, much like in photography, but virtual, both in terms of lighting, set styling, and props. So what I needed to do was get rid of the background and some of the transparency in the glass parts of the image. In order to do this, you just need to select the subject, get rid of everything but the subject, and then create a bit of transparency here in the glass parts of the image. That is, if you have a transparent subject. Once that was done, all I needed to do was recreate a set in a 3D environment. Now, I am using Blender, but you can use anything else. You can use Cinema 4D, you can use Houdini, you can use anything. It all depends on what you need to do. Like if you had to do a volume animation, for example, I would do Houdini. If you had to do a particles animation, I'd probably use Cinema 4D or Houdini as well. But in my case, I wanted things to remain simple because I just needed our subject over here, our backdrop over here, and a prop here. So I set the scene, and you can find all of the elements and the scene as well in the description below. You can download all of them and recreate this scene yourself. And the only thing I had to tinker around was setting the perspective right in relation to the camera of our subject. But once that was done, all I had to do was just set some lighting over here. We have a key light from the left, a fill light from the right, and a bit more of a fill light from the top, and then I just had to render out our frame, like so. Now, as you can see from the render here, this approach of 3D only would not work well, and that's because we have a 2D image acting inside of a 3D environment. But since we can now relight inside of Stable Diffusion while preserving details and colors, we can use this image as a source image inside of Stable Diffusion and then decide whether or not we want to go as far from it or as close to it as possible while relighting it, preserving details and colors. So going back inside of comfyUI, we are now starting from our render. Now my render aspect ratio is 16:9, and that's because while I'm doing this, I'm also working on the thumbnail for this video, so I'm resizing it to a 16:9 aspect ratio, so that's 1920 by 1080. And since this workflow is a one-click workflow, let's change things out a bit from this example. And so let's say we want to go for studio light advertising photography of a perfume on an ice sculpture. We're gonna copy that, put that inside of the clip test and code field for the relighting as well. Let's make sure that we have the right prompt for the segment anything. In this case, it's a bottle, so it's going to be saying a bottle. And then let's use an ice reference for the IP adapter. So I'm going to drop an image of some ice in the IP adapter load image node. And let's say I just want to influence the branch to turn into ice. Everything is ready, so I'm just going to hit Q prompt and speed things up so you can see that there's no trick to it. And there you go, here we have our results. Let's start with what was the original output of the previous version of this workflow. The ice sculpture is wonderful and is retaining the same kind of structure from the original render, while allowing us to recreate something different from what we rendered, all the while without caring about shaders, for example. But as you pointed out in the previous video, the color of the subject is not quite the same. Now let's take a look at our 3 different color matching options. The one on the left, as I said before, is based on a color match node. The one in the center is based on an image blending mode node set on hue, and the one on the right uses a color match node as well, but instead of being set on the segment anything mask for the subject, is set on a mask for everything that is being lit. Now, as far as I'm concerned, choosing between these 3 is a matter of personal preferences. As a photographer, exact color matching is only required for e-commerce pictures and catalog pictures, whereas for advertising and editorials, exact color matching is not as required as adherence to mood and feel. So that's why I haven't set any of these 3 different options to maximum blending of color matching. But if you want to do that, for example, you can just tinker around with the blend percentage values here, and here, and get results that are closer or further away from the original color. Now, what's going on here in these subgroups before the image is previewed is that we are recalculating the low frequency layer as well. Since the low frequency layer takes care of color and lighting, we have to recalculate that. And if we zoom in a bit, on these tiny preview images that are previews of the low frequency layer, we can see that in some of them the original color is well preserved, while in others it's less preserved. In this hue option, for example, the option 2 for color matching, the original color is not that well preserved. Now, it is a matter of both tinkering with values here, mostly in the blend percentage value range, and of the scenes you are trying to recreate. In this case, option 1 and 3 work better, but in other cases, option 2 might work better. And that's why I left all 3 of them for you. But what is it, you say? I don't want any ice. I want an actual branch like I did in the render. Well, good thing that we have a VAE encode node over here. This VAE encode node sources the image from the start from existing product image load node. That means if we substitute the latent in the case sampler for the re-background and we don't use an empty latent image anymore, and lower the denoise, let's say to 0.6, changing the prompt to on a wood branch, and changing the prompt for relighting as well to wood branch, and disable the IP adapter group because we don't want ice anymore, and hit Q prompt. And there we go, we get a good looking branch right away, and we get some good color matching as well for the subject. We can also lower the denoise even more to keep the same exact background from the starting image. Now, if we bring in the original image from the start of the video, where the wood was turned into wool, and the wool was based on a Marni reference, and bring in some logos, let's say this was a collaboration of sorts between Maison Margiela for the perfume and Marni, this to me looks like a good campaign. The lighting is consistent, the branding is consistent, the details are consistent, and the colors are consistent. You can see how this can be a very powerful workflow for real-life use cases. But I was teasing you about animations as well in the beginning, so let's take a look at that. Well, if we open Blender and scroll through the timeline, you can see that I've added an animation, a very simple one, to the branch. Now, this is all theoretical yet, because I only had some time for testing the initial stages of this, and I hope to further develop this. But if we render the frames of the animation, or every fourth frame like in this case, and then pass them through our workflow, you can see how the lighting is consistent enough, the materials are consistent enough, and the details are consistent enough to use this as a base in an animated diff workflow. In some cases, like where the fabric is tearing and going in front of our subject, we might have some detailing issues, but remember that this is one single frame and you're not going to see it as clearly in a full animation. So theoretically, it would be possible to create an animation out of this workflow. The only limitation you'd have is that you're working with a 2D representation of the subject inside a 3D space, so the camera and the subject must always have the same perspective. They have to be locked in. So if you want to do camera movements, for example, you can't just go around the subject because there's no subject here to the left or to the right of it. It's just a 2D plane. And so the subject would always have to be perpendicular to the camera. Now, if we had a good way to create 3D objects starting from just one picture, and we are not quite there yet with Stable Diffusion, we would solve that as well. So all in all, I am very, very excited about the possibilities of this workflow. I have been receiving a tremendous amount of support and interest in this workflow, and I have seen some of your creations as well, and I think this is a great step forward in what we can achieve production-wise with Stable Diffusion. So that's gonna be all for today. I hope you had some fun and you can create new stuff with this version of this workflow. If you like this video, leave a like and subscribe. My name is Andrea Baioni. You can find me on Instagram at risunobushi or on the web at andreabaioni.com, and I'll be seeing you, as always, next week.